Okay, so we are just, before taking a test, we're moving right along to the next chapter. We talked about this before. The last few chapters, if we're talking about expressions, equations, inequalities, what we're talking about getting into is something called functions. You'll see they are all extremely closely related to each other. And that's why your test is all kind of grouped in one, because it's all kind of interlinked. All right, so what we're doing is we're moving on to chapter 9. And we are talking about, like I said, we're going to start with the basic, and something called functions. So our vocab here, the very first word, and it is tiny, so sorry about that, so listen carefully. The first word is function, everyone. Function. All right, so here's what a function is. It says a function is a special relation in which each element of the domain is paired with exactly one element in the range. Now, really quickly, I just want to point out, your domain are going to be your x's, your range is going to be your y in an ordered pair. So obviously that leads you guys to know that we're going to be talking, kind of extending the ordered pair and how it's relating to equations. And so for example, if you have a set of ordered pair like this, 3 and 4, 2 and 5, that would be a function. However, 3 and 4 and 3 and 5 is not. Because if you take a look, here's your x, here's your y. Here's your same x, there's a different y. And that would mean that there's not exactly one element in the range. There's two. And that wouldn't be what's called a function. Okay? Now there's a lot of different ways to look at that, and we're going to be talking about that here in this lesson. Okay? Our next word is called independent variable. Everyone? Independent variable. All right, so an independent variable, your book says this is the variable in a function with a value that is subject to choice. Okay? The variable in a function with a value that is subject to choice. Now that probably sounds weird to you, but we'll talk about it here. This is usually your x value that is chosen first. Okay? That is called an independent variable. And the y value is what we'll call, it doesn't matter. It will matter, but it is going to come off of the equation basically. All right, we'll talk more about that. And that is, of course, our next part. And that is a dependent variable. Everyone? Dependent variable. All right, so this is the variable in a relation with a value that depends, right, on the value of the independent variable. So here's what you need to know. This is usually the y variable. It all depends on the x variable. Now, I want to take you guys back before we go on to make sure that you understand what these two things are. Okay? Remember on our POD. Remember it was talking about the perimeter, and we got it from whatever 10 times W was, right? The width. So, remember that we chose to put the second half of that question is what happens if the width is 8? Ladies and gentlemen, we just plugged in an independent variable because we can plug in anything we want there. It's independent of anything else. However, remember our answer? This is a dependent variable. It all depends what the independent variable is. Okay? So that's what it means by independent and dependent. Okay, the independent is the one basically you plug in. The dependent is going to be pretty much your simplified answer. And that's just kind of putting it in a basic term. Okay? This is your answer depends on what number you plug in. Should make sense, right? So that's a dependent, or this case would be a dependent variable. Okay? Okay, now there is another phrase here, the vertical line test. Everyone? Vertical line test. All right, so here's what the vertical line test says. If any vertical line is drawn on the graph of a relation that passes through no more than one point on the graph, for each value of x in the domain, then the relation is a function. So you see function up here, and when I talked about this right here with our example, okay, this is, I showed you one way to test if something's a function by looking at the ordered pair. However, if you don't have the ordered pair and the graph is there, then you use, this is an alternative. These are if you have the ordered pair. If you have a graph, though, you do a vertical line test, and that will tell you if it's a function or not. So in your example, if you just draw like a vertical line, meaning if you draw a vertical line through a graph, it should only hit one point that is equal to x. Because if it hits 2, okay, that means that you have 2 y's there. Okay, 2 y points for that one x. Okay. All right. The next phrase or vocab is function rule, everyone.
Function rule.
All right. This is the operation performed on the input of a function. The operation performed on the input of a function. Basically, guys, it's the equation. So if you have something like y is equal to 2x plus 3, kind of like this, p is equal to 10w, the 10w was our function rule. And in this case, y equals 2x plus 3, the function rule would be 2x plus 3. It's the equation that you use when you plug in the independent variable to get the dependent variable. When you plug in the number to get the answer. Okay? And then the next one is function notation. Everyone?
Function notation.
Okay. Anyone remember what the word notation is? Scientific notation? It's been a little while. Does it sound familiar? What's the root word of notation? Note. A note or a piece of writing. Basically, this is the form of writing that you'll write a function in, or you'll see it. Okay? And that's what this is. A way to name a function that is defined by an equation. And here's the proper way. If you have an equation like I had used earlier, y equals 2x plus 3, you will see a function written like this. The function of x when it is equal to 2x plus 3, when the rule is equal to 2x plus 3. Okay? So if you take a look, the function of x kind of takes the place of course, y. Okay? So today's lesson, and the reason why there's so many vocab words is because today's lesson is very vocab based. A lot of it is, this is pretty much going to tell you how to do the problems we're about to do on many of them. Okay, now we're going to use a little bit of other things involved, okay, that from our past lessons, but this is a lot of what you'll see. Okay, so with that said, all right, go ahead, and your book should already be open to this page, but if it's not, go ahead and go to page 387. 387. All right, on page 387. Okay. On page 387. Let's take a look. If you're not already there, right? Just talk about it. Problems. Let's start with problem number 1. Okay, number 1 says determine whether each relation is a function. Explain. Okay, so 1 and 2, even though they're under the same category, they're a little bit different. These are already set. The set is already put in ordered pairs. This set is not in ordered pairs. All right, so let's go ahead and start here. Now remember what a function is. All right, remember, and just make myself a little note as a reminder. Okay, a function is that basically every domain, which I said is an x, has exactly one y. If that's the case, then it's a function. If it is not the case, then it's not a function. So it just says determine whether each relation is a function. Explain. So here we go. First of all, I take a look here. 8. Are there any other 8s? No. Here's a 4. Are there any other 4s in here for my x's? No. A 6. Are there any other 6s? No. Here's a 1. No other 1s. At least according to this, okay, of what our information is, I would put this is a function. It does say to explain, so if we're going to put these as in steps, I would say step 1, test, all right, with the definition. I'll put define here, but test with the definition. Step 2, state whether it's a function, yes or no. And then step 3 is make sure you use the word because. All right, with of course the explanation, because that's what it's asking for. This is a function because all of the domain, okay, and if you want to take a look here, the domain, and you can use this definition, is paired with exactly one element in the range. Okay, so each of the domain has been paired with exactly one element in the range. Okay? Let's take a look at problem number 2. Okay? I'm testing it. Here we go. Here's a 1. It goes with a 4, but are there any other ones? So far, so good. Here's a 3. It goes with a 2. Are there any other 3s? Yes. This 3 of a domain has a range of a 2, but look, it does not have exactly one value for range. It has 2 different values. So I just tested it. Now I'm going to go ahead and put this is not a function because you could even be specific. The domain of a 3, oops, has 2 elements in its range. And to be specific, I could put 2 and 4, right? So when x is 3, one of them shows it's 2, another one has the y of 4. Okay, so just a couple of different ways that you can look at it, ordered pair on a table, and find out to test it, and then how to properly explain. Okay, questions on that type of problem? Could have you guys try one that's similar. Okay, here's the one I want you guys to do. Try out problem number 10. Problem number 10. Okay, how many of you need more time? Okay, a few more seconds there. Thank you those of you that have gotten your logs stamped. Okay, just remember, hopefully I'm here on Friday, all right? Log was due today, so make sure you guys get it signed tonight. Okay, 30 seconds. Go ahead, turn to your neighbor, and share your full answer with them for number 10. Go.
This is not a function, but I didn't finish.
All right, here we go. All right. Basically, just read me your sentence, basically. All right. Here we go. Seat number 1. Okay. Did you raise your hand when I asked who needs more time? Okay. Please make sure you do that next time. All right. Where I can track that. That way you can share with your neighbor as well. All right. Seat 28. 28. Sorry, just a little bit loud. I heard this is a function. Okay, agree, disagree. What do you guys think? All right. Anyone else have something different? Okay. All right. Well, if I take a look, right, I check out all my x's, and at least according to the what they tell me right here, it appears to be a function because all the x's, none of them have different, there's no same x's with a different y, right? Or none of the same domain that has a different range from each of each other. All right, so any questions about that? Okay, all right, so let's take a look then at problem number 3. Problem number 3, we'll go back up to the top. Okay, if you take a look, number 3 is exactly under the exact same directions that we just did. Determine whether each relation is a function, but it is graphed. And if you remember right, when we were talking about our vocab, I said this is one way if you have ordered pairs that you can take a look if it's a function. However, if it's already graphed, use your vertical line test. If you talk about a vertical line, that means you are running a vertical line that is even with one particular x value if it's vertical, right? If I run a line here, or even if I run a line here, if this is 1, I'm running a line, okay? That plotted point here is, my line would only go through one plotted point. This one, I run it here. How many points is that going through? 2. So, ladies and gentlemen, this is not a function because it passes through 2 plotted or graphed points when I test it with a vertical line test. It's as simple as that. So whichever, it doesn't even tell you the value. I'm assuming maybe that is when x is equal to 1, 2, 3. But either way, when x is equal to 3, then y would be equal to 1, 2, 3, 4, and 5, 6, 7. 4 and 7. So therefore, that's why the vertical line test works. Because it's doing the same thing we did up here, but by testing it out with the plotted points. Okay, questions on number 3?
So it doesn't matter when two y's are the same?
So it doesn't matter when two y's are the same. If you take a look, right, these two y's are the same here. And that'd be okay if that plotted point didn't exist. Okay. Other questions?
So if there's just like 2 in one x, then that would mean that it's not a function?
Right. Yep. So if you look at it here, right, 2 in 1x, so look at 1x is 3 and 3, but there's two answers. And right here, this x is actually 3, and there's 2 answers. But you test it in a different way. You could still test it the way we test this, but it'll take a little longer. The quick way is just doing the vertical line test. That's the quick way on a graph. Okay. All right. Questions on that? All right. So here's what I want you guys to try. Try problem number, 16. Try 16. Okay, 16. Go. All right. Anyone need more time on that one? Okay. Okay. 30 seconds. Go ahead and turn to your neighbor and share your answer. Go.
I got this is not a function because it passes through two dollars when I test it with a vertical line test.
This is not a function because it passes through 2 points when I test it with a vertical line test.
All right. So everyone shared pretty quickly. Not a lot to talk about, right? So let me go ahead, pull a seat number. All right. Here we go. Is number 16 a function? Why or why not? Seat 12.
This is not a function because it passes through the plotted or graph points when I tested it with a vertical line test.
All right. Agree, disagree. Okay. Plot it here, right? Vertical line test. It'll hit 2 points right there. So, not a function. All right. Okay. Let's go ahead and let's take a look now at problem number 6. Problem number 6. Okay, here we go. For problem number 6, let me refold my paper differently. All right, problem number 6. Okay, the directions say if, and look how it's in, look how it is in function notation. Okay, it says if the function of x is equal to 6x minus 4 with the function rule, right? It says find each function value. So here's ultimately what it's saying. It's saying what happens when the function of x is negative 5. So here's all it's saying. Step 1, write your function rule. Step 2. Tell you what, let's go function notation. Let's make sure we do it the right way from the very beginning. All right. Function of x equals 6x minus 4. So step 2. Go ahead, plug in what they're giving us. It's negative 5 for x. Step 3, I'll put it over here. Simplify. Simplify the expression on the one side. So we have function of x equals, and then 6 times negative 5, do the multiplication first, is negative 30. Rewrite it, minus 4. And the function of x equals negative 34. I do want to point out, look how I'm working downwards. I still see some people struggling on their homework, and they're not doing that. Okay? Guys, we've talked about it a lot this semester. That's extremely important. Okay? We are getting towards, we're not there yet, but we're getting towards the end of this semester, end of the school year is coming, and you will see huge problems. If you think you're going to work all this sideways, you're going to lose yourself in your problem. If you haven't started already, make sure you're working downwards. Okay? We've already gotten to some bigger ones, and we need to make sure we work down. Okay, so on these kind of problems, that's all it's asking. Okay, any questions?
So the f and x don't have meaning. Oh, do they have a purpose for the answer?
Yeah. I mean, it's stating the solution. It's stating your answer. If you box it in, that's fine. Okay, I'm not going to be picky about that part right now. I do want you to show it though as part of being your function notation, at least within your problem. Okay. Okay, guys. Any other questions? Okay. Problem I want you guys to try out is problem 22. Down at the bottom there, 22. Try that out. Go. Okay. How many of you are still working on that? Okay. Okay. All right. 30 seconds. Go ahead and turn to your neighbor and share. Go. Okay. So, problem number 22. They do give us g of x this time, a little different, equals 5x plus 4. All right, so, bless you. All right, so just, excuse me, looking for a solution. Your function, your g of x equals what? See, 32. All right. Agree, disagree. What do you guys think? All right. Okay. Any others out there that want to be shared? Okay, well, let's check it out. So, number 22, they said that the g is going to be 7. So, I'm going to go ahead. G of x when the x is 7. So, I go ahead, work downwards, do my multiplication first. And we have g of x is equal to 39. Okay. Questions?
Will it, does it matter if it changes, like, for example, for the other problem, it was like
F of x?
yeah, and g of x?
So
Will
this,
change all?
it doesn't matter. It will change occasionally. This is your most common that you'll see, all right, through school. All right, but sometimes they will have something different. You'll talk about that as you get older. Okay, just be aware.
Why do we put the x in parentheses?
Are you talking about right here, or are you talking about here? That, I mean, right now as a 7th grader, guys, this is what you need to realize. That is just function notation. Okay, so we'll talk about it later if you guys want, but right now that's kind of what you just want to get used to. Okay, that's just how functions are written. Okay, that's a good question. All right, other questions? Okay, let's take a look at one more. Let's take a look at problem number 9. Let's take a look at number 9. All right, here we go. Let's go ahead and close read number 9. It says, the Milligan family spent $215 to have their portrait taken. The portrait package they would like to purchase costs $125. In addition, the photographer a $15 sitting fee per person in the portrait. Okay? So, here we go. We have a two-parter here. It says, A, we're going to need to identify the independent and dependent variables, then write a function to represent the total cost of any number of people in the portrait. And then it turns around and says, use the equation to find the number of people in the portrait. All right, that's B. Okay, so here's what we're going to do. Let's do this first. All right, step 1 is let's go ahead and let's start with drawing a bar diagram. And here's what we're going to do. Let's answer part B first. You'll see that part B is a little closer to what we've been doing. So I know it's kind of going backwards, but it will help you out in these problems for right now. Let's start with part B first. So to be able to do that, let's do step 1, draw your bar diagram. Step 2, remember we put the total up top to organize our work here. It says they're spending a total of $215 for this portrait to be taken. Okay? Then it turns around and says the portrait package they would like to purchase costs $125. Okay, so that ends up being, and this is step 3, a flat fee of $125. But, however, they are going to have an additional charge of $15 per person. It's a sitting fee. So, 15, 15, 15, I'll just put dot, dot, dot. It's repetitive because we right now don't know how many people are sitting there. Now, from what we've been doing, we write equations. I'm going to go ahead. I'm going to write down the bottom as an expression. So it's $125 plus our 15 times however many people are sitting there, X. That is going to equal $215 because that's how much they said they spent. So it says use the equation to find the number of people in the portrait. We're doing part B, remember. So we're going to go ahead. Step 5, we're going to solve this. So I go ahead. Here's our variable term. I stay on that side. I'm going to do additive inverse first. So I'm going to subtract 125 from both sides. So those cancel. I end up with 15x equals, and I'll do a little bit of borrowing here. So 5 minus 5 is 0. 11 minus 2 is 9. 1 minus 1 is nothing. X, remember, is how many, of course, people are in this portrait. That's what we're trying to solve. So I continue 15 times x. So I'm going to divide by 15 here, by 15 here. And x equals, if you get lazy, you can punch in the calculator. 90 divided by 15 equals 6. And of course, this is still part of a word problem, so put your units on there, and I guess we could call that step 6. 6 people. Now remember, this is 9b. We're working backwards. Started with what's more comfortable for you guys. We used an equation to find the number of people in the portrait. So there's our equation. We used it, found our answer. Okay, now, before I go on to 9a, let's just take a quick break. That's pretty much review, but I want to use this time. Any questions on that? Okay, here we go. Now let's do 9a. Now 9a, we're actually going to work completely backwards. Even on 9a, it says identify the independent and dependent variables, then write a function to represent the total cost of any number of people in the portrait. Okay, so here's what we're going to do. We're actually going to write the function first. All right, so maybe we'll make ourselves a little note here. Function. So I'm not even going to write a step. Here's what the function is. It is this expression, because that expression there is our function rule. So here's what we do. F of x equals 125 plus 15x. Better yet, it should be probably 15x plus 125. There's our function. Now, I guess you could even call that independent thing step 1. All right, use your expression. There's your function. Okay, we're not putting 215 there because this is a very generic function rule. It's not saying they use 215. It says write a function to represent the total cost of any number of people in the portrait. Okay. Now comes we'll say step 2. And here we go. It's a two-parter. First of all, well, I guess we'll call step 2 just one part. What are we, this is a little note, what are we plugging in? I know we're plugging in an x, but what does that x represent? Take a look. If you forgot, that's why I did 9b first. What did the x represent here?
People.
Okay, it didn't represent 6. It represent the number of people that are going to be sitting down in the portrait. So what are we plugging in? It's the x, but in this case, it is the number of people that are the number of people, and this is our answer, who are in the picture. So the number of people who are in the picture, here we go, is our independent variable. Remember with our vocab, independent variables, okay, it's the x value. It's the one chosen first that you're plugging in. And that's, of course, what are we plugging in? It's the number of people. So the number of people who are in the picture is our independent variable. Step 3. Our dependent variable, which is all depending on how many people are sitting in the photo. Our dependent variable is what, guys? What's happening over here? What's this giving us? What was our answer here? What did 215 represent? The cost. That's the cost, the total cost of the picture. What do they call it? The picture package, or just the family portrait? Our dependent variable is the total. We'll just put the total cost of the portrait. Dependent is how many people are sitting. That's what you plug in. That's going to be given. Sorry, did I say dependent? Independent? The dependent one, okay, it all depends on how many people sit. The price depends on how many people sit down for the picture. So in this whole thing, on your homework, that's an answer there. Okay? There's an answer there. There's an answer there. And there's an answer there. If this was a test, this would be worth 4 points, basically. If they were asked in this way. So, the answer, if they're spending $215, however, the function written, what is the independent and what does the dependent variable stand for? Okay. Questions on that? Okay. Here's the one I want you guys to try. Try out problem 26. 26. Okay, how many of you need more time? All right. Okay, how many of you need more time still? Okay, I'll give you guys a countdown here on 30 seconds, and then I'll have you guys share. Okay, there's a lot to share, right? Make sure that we're sharing part B, okay? Using that to write our function, or the equation in part B to write our function. And then using our function along with what numbers we're plugging in here and our answers, of course, talk about what is the dependent variable and what's the independent variable. All right, so I'm going to give you guys 1 minute. Share basically those 4 answers with your neighbor. Go.
I got the number of minutes is the independent variable and the dependent variable is the depth of the stripper.
Okay, here we go. Now guys, I mean, this is a lot of new vocab for you guys. The math part, the actual calculations, I mean, there's not a whole lot new here. It's just a different way of writing it. You got a lot of vocab, a lot of vocabulary. So, I mean, that's what's new. So I would really recommend use your notes. All right, your notes will help you. All right, so if I take a look, all right, I'm going to use my notes right here on 26. All right, so what I said in our notes, right, was do part B first, 26B. So I'm going to write the equation, all right, based off of what this expression is up here, or this story. So it says a submersible descends to a depth of 1,500 feet at a rate of 40 feet per minute to explore an underwater shipwreck. So step 1, I'm going to draw my bar diagram. Step 2 is the total. Well, it descends to a depth of 1,500 feet. That's its ending spot. So, a depth of 1,500 feet, you could almost, if you wanted to, you could say negative 1,500, right? Because it's going down. All right. Step 3 in this whole ordeal is what's going on in the bottom here, where there's no flat fee, or there's no flat, like, oh, it started off at 250 feet into the water. It doesn't start off with anything. It doesn't add just a flat thing of what is in this story. It's starting off at sea level, and it's going 40 feet down. It's dropping 40 feet, a rate of 40 feet per minute. So after the first minute, here's a negative 40. After the second minute, negative 40. After the third minute, negative 40. After the fourth minute, negative 40. ... It's repetitive. Ladies and gentlemen, if I'm writing this, right, this bottom here, bless you, is negative 40 times, okay, it's just times what we don't know, which is the x. In this case, if I reread this, it says use an equation to find the total amount of time it took. So x is, of course, the number of minutes. So remember, the bottom is equal to the top. So the next part, right, is after I have my equation written down, I'm going to solve. So basically, it's a one-step equation. I box in my x. I'm going to divide by negative 40 here. Whatever I do to one side, I do to the other. X is equal to, well, let's find out. We have 1,500. I'm going to ignore because a negative divided by a negative is a positive. So 1,500 divided by 40 equals 37.5. So, ladies and gentlemen, I'm going to put my units on there. 37.5 minutes. So 37 minutes and 30 seconds. Okay? Part B is done. Working backwards. So here we go. 26a. I'm going to go ahead and build my function. So write it in function notation. F of x is equal to, and take a look at my function rule here. It's not 1,500 because that's the end point. All I'm doing is looking here. It's negative 40x. And there's our next answer. There's our function. And then, here we go. I'm looking here. What are we plugging in? Remember, that is our independent variable. So I'm looking, that means what is the x? The x, of course, is, well, x is equal to 37.5 minutes. It's the number of minutes that the submersible is descending. So that is exactly, so the independent variable is the number of minutes in which the submersible descends. The dependent variable. Well, before I answer that, okay, remember it's what is it giving us? Well, I plug in the minutes here. Remember, what is the total here? It is how deep is the submersible at the end. So the dependent variable is how deep the submersible would be or has gotten after that amount of time. Okay? And they're, of course, independent and dependent variables. Okay, guys, questions? You have your answers in front of you. You guys shared with your neighbors. Any questions?